right, we're here with our AP Statistics class, my favorite P3 class that I teach this school year. All right, so we have a two-way table. All right, what are the two variables we're looking at in this table?
Eye color and handedness.
Very good. All right, so dominant hand and eye color. We want to see if there's a relationship between these two categorical variables. So we're going to run a chi-square test for independence. So if the AP exam is nice to you in May, it will be very clear with its question of like, is there a relationship? Is there an association, right, between these two variables? Right, if they don't have that, you got to kind of figure out what they want you to test. Okay, so the first thing I'm going to do is I'm going to write my null hypothesis. Any ideas what we're going to assume to be true right now?
That the eye color and handedness have no association.
I love it. So I'm going to write handedness and eye color are independent. And you can write they have no association, they have no relationship, something like that. So that's our null hypothesis. That's what we're assuming to be true right now. What are we going to try to prove? That there is a relationship, there is an association, or you could say they are related or not independent, or you could even say they are dependent. Any questions so far on the hypotheses? Remember, just a reminder from Monday and Tuesday, do you need to do anything with parameters? No, just go straight into your hypotheses, okay? Yes. Monday, Tuesday was the goodness of fit test, and then Tuesday was the homogeneity test. So if it's chi-squared, you don't need... Oh, no, sorry, this past Monday, Tuesday. You were here, Thomas, don't worry. Watch the video if you forgot. Okay. The assumptions, we've got to make all these assumptions, same thing we did on Tuesday. All right, we're assuming independence between these different counts in my cells. What would worry me about these students in terms of eye color and handedness? What would worry me about independence? If they're related, nice, thank you very much, right? If there's any relationship between any of them, right, that would worry me about independence. But if they're not, I'm probably cool with it, all right? Randomization, does it say randomness? No, it doesn't, right? So these students are a good representation of all students. It doesn't really give us a whole lot of information about where these students are coming from. It just says some class, right? It says from a class. All right, so this is one class. All right, I'm going to go back to the first slide to get some totals here. All right. How many of these students are left-handed? 19. How many right-handed students? 95. Okay. How many have brown eyes? 42. Blue eyes? 33. You're good. And then other eye color? 39. And my personal favorite, people that have one of each. You guys met anyone that has one of each? Oh, man, it's the coolest thing. I'm sure you learn about that if you take anatomy. Yeah? Yeah, is that what it's called? I don't know what it's called. There's a name for it. Sick. Love it. Okay. Anyone have an idea for the grand total? I got to close caption that, man.
114.
114 is right. All right, this is the grand total. Remember, just a reminder from your days in probably elementary school, don't add all of them together. You'll get double, all right? So just add one of these totals, okay? Okay, so now the reason I brought that up is because what is 114 times 10? 1,140. So, again, I don't know anything really about what's going on. Not a whole lot of information here. but I need my population to be more than 1,140 students. So what I'm thinking is this is probably not, I mean, could be, but probably not a high school, all right, at least in terms of the size of our high school. But maybe we can think of it as like a college course, all right, 114 kids in a college course. Many of you will be in classes in the fall where you have more than that in one course, right? Especially you have a huge class, okay? All right, sit in the front. Do it for me. Sit in the front. All right, sit in the front. So I'm going to write down that I hope there are more than 1,140 students that could have enrolled in this class. That would make me feel good about the 10% condition. All right, we got to make sure we're talking about categorical variables here, right? You just look at someone and you ask them, what is your eye color? All right, and you put them in a category. All right, same about what your dominant hand is. So yes, these are both categorical. All right. The sample size assumption. We need to assume that 114 students is a large enough sample. And the condition that we check with chi-squared, just like we did on Tuesday, all right, and that we did on Monday, we check to make sure that our expected values are 5 or more, all right, so at least 5. So I'm going to ask you guys, do you want to do the clunky way or do you want to use the technology? The technology? Oh, man. No one out there wants to do clunky way. Sad. I would have been that kid. Oh, yeah. In high school, when the teacher like clearly doesn't want to do it, I'm like, oh, let's definitely do it that way then. All right. So this is actually good practice for Maria and Jonathan. You watched the video? Look at you. Oh, my God. You're amazing. Okay, well, hopefully they were okay. All right, as long as you got it cleared by corporate, we're good. Okay, so what I'm going to do is I'm going to go to my matrices. I want to input some rows and columns for a matrix. So remember, second matrix. I know. God, those were the days. Life was simple. All right, just solving for x. All right, I'm going to go over to edit. And I always just choose matrix A, but whatever you want. Don't be alarmed if it says there's something in there. No worries, we're going to put something else. All right, so even if it's different, we're just going to blast right through that. All right, so how many rows and how many columns? 3 rows and 2 columns. You're good, just the data. Be careful with that. They'll try to mess you up on the AP exam with totals. All right, so 3 by 2. So 6, 36. 7, 26, 6, and 33. So I'm going to run the test, okay? But I'm going to hold off on kind of taking all the information. So I want to complete the problem. So I'm really just doing this to get the expected values for each of these cells, okay? Now I'm going to do a lot more work today than you have to. I'll make it very clear what is expected on the AP exam. And I'll show you why I'm actually doing all this work. So go to Stat, over to Tests. Remember, we're doing the chi-squared test. Am I doing goodness of fit? No, right? So the calculations for the test for homogeneity and for independence are the same. That's the confusing part. That's the tricky part. The work is the same. Yeah? Okay. So letter C. All right. I put my observed in matrix A. I'm telling it to put the expected values in matrix B, and I'm going to hit calculate. Again, we'll get to that later, right? Obviously, we'll need that. But for now, I'm going to go back to second matrix. And just in this names part, right, second matrix where it says names, if I go down to matrix B and hit enter on that number 2, then hit enter again, these are the expected values. All right, so I'm going to fill these in my table. As you're filling them in, are we concerned? No? Are there any of them that are not more than 5 or 5 or more? Close, right? But we're okay. All right, so according to this, our sample size is large enough. So once you finish this, right, and don't forget to actually check this and put it to the side so that the AP exam scorer knows that you actually checked it. All right, we are ready for our statement, and I believe I put the statement for you. Yes?
Is this the only condition because it's like tailored to the problem, or is it always in every problem where it's always have to be at least 5 for it to be?
For chi-squared, it's always going to be 5 or more for each cell. I put this little blurb here that we've done something similar to like this called the success failure condition back with proportions, right? And that the number was 10. And you might even take a course in college where your professor uses a different number. They might use 5, 10, 15. It's really up to the professor. All right, most people use the 5 and 10. Okay. All right, so here is the statement. We're going to run a chi-square test for independence with 2 degrees of freedom, the same way we calculated degrees of freedom on Tuesday. It's the number of rows, which I believe was 3 rows, minus 1, and then times the number of columns, which is 2, minus 1. So 3 minus 1 is 2. Times 1 gives me 2 degrees of freedom. All right, we ready for the mechanics? All right, so essentially now when I do this, all right, I'm going to do this slide to fill all these cells here. Do you need to do this step on the AP exam? No. All right, I do want to make sure that you have practice doing this because they might throw in a multiple choice question where they ask you to calculate with your calculator a chi-squared component. So I want to make sure you are at least familiar with that. All right. On the AP exam, don't need this. All right. What did you say? Oh man. I got really embarrassed. I said it with my 8th period class, and they just I have an eighth period AP stats, and their look of just like there's so much judgment. And so now I'm like self-conscious about.
Don't worry, we love it.
I know, but like,
You're like Lady Gaga.
No one's ever called me Lady Gaga before. Okay. 6 minus 7. This is observed minus expected. Don't forget to square it over expected. So 6 minus 7 squared over 7. For right-handed, for brown eyes, it's 36 minus 35 squared over 35. Okay, back to the blue eyes. 7 minus 5.5 squared over 5.5. Right-handed, 26 minus 27.5 squared over 27.5. And then for our students that do not have brown or blue eyes, we've got 6 minus 6.5. And the right-handed, 33 minus 32.5. All right, and again, you do get this formula on the AP exam, all right? But yes, you have memorized it with a hey! Something like that. No, bro, see, bro, that's the feeling. That's the feeling.
Bro.
Makes me sad.
Get him out of here.
It's okay. All right, I'm going to go in and type these in. Again, I want to stress, you don't have to do this, but I want to get each chi-square component for each of my cells to see what's driving it, if you will. So I'm going to start with the first one. 6 minus 7, right? 6 minus 7 is a -1, but when you square that, it becomes +1. So I really just need to do 1/7, which is 0.143. Okay, the other one is another 1, right? 36 minus 35 is 1. 1 squared, 1. So I'm doing 1/35. 0.029. moving to my blue eyes. This is 1.5. Some of you may know 1.5 squared, but I'll do it for us. And then divide that by 5.5. So 0.409. And then this is actually 1.5 again, but it's a negative. I don't care about that. So positive 2.25 divided by 27.5. 0.082. And then going to my students with not brown or blue eyes, this is 0.5 squared or negative 0.5 squared, which you probably know as well, but I'll show you. Divided by 6.5. 0.038. And finally, the last one is 0.5 squared again. So 0.25 divided by 32.5. 0.008. Yes. Now, I haven't actually added these up. We can go back to our test to do it. But my first thought as I look at these, what do you think my first thought is as I look at all 6 of these numbers? What do you think my first thought when I look at those 6 numbers? It's okay.
Blue is way bigger than
Blue is the only one that even like approaches 0.5. My actually first thought is these are all small, right? If you look at the work that you did, are we really that far off from the expected values here?
Yeah.
No, right? So I'm not surprised that if we're really close to the expected values, we're going to get a small chi-squared component. So what my first thought is, I'm not expecting this chi-squared value to be very large. And if you don't have a very large chi-squared component, you're not going to have enough evidence to actually reject the null. All right, so let's get all that data now. I'm going to go back to my calculator, run the test again. Remember, it's letter C. You've still got it, hopefully, in the same stuff. And here is my chi-squared. So adding them all together doesn't even eclipse 1. Chi-squared is 0.708. All right, so I'm going to draw my curve. Skewness to the right. Notice how on this one I drew a much bigger area than I'm shading. Because what is my p-value? Yeah, it's 0.702. That's a very large p-value. And hopefully you know that if your p-value is large or big, you're not going to have enough evidence to reject the null. All right, so I'm going to write that down for my conclusion. Our p-value is large. So I will fail to reject the null hypothesis. All right, so if I'm failing to reject the null hypothesis, right, I am going to go with my best idea right now is what's the relationship between your dominant hand and your eye color?
None.
There is none. All right, they're independent of each other. So whether you're right-handed or left-handed tells me nothing about what your eye color is. What your eye color is tells me nothing about your dominant hand. All right, so I'm going to say handedness and eye color. I don't want to use that word. You should only use that word. You can say are not associated. They have no association. There's no relationship. You can say they're independent. The reason I'm making us think about this, Thomas, is because in the world around us, society uses correlation incorrectly all the time, but it's just accepted. Right? The number of times I hear people use the word correlation when they're not talking about quantitative variables is a lot. Right, even in meetings here, and I'm like, that's not the word. Okay, so in this class, you definitely cannot say correlation. That's only for quantitative variables. These are very much not. They're categorical. All right, so not to call you out, Thomas, but make sure that everyone knows what Thomas said was not okay.
I think he called me out.